So this is what about the velocity. So if you want to find the velocity of a particle on a rolling, pure rolling, anywhere you can use the formula 2v sine theta by 2. That's the formula will give you the velocity at any point. Now let me take that now. The next one, if I take again take a rolling, pure rotation, if you take it. So pure rolling means with respect to point P, contacting point. What is the velocity of a point P? Everybody. Velocity of a point P what? 0. So means or else if you take, if it is acceleration. So both, if I take this jet point and this P point, both must have what? Rate of change of velocity is 0. Both must having what? Everybody? Both must having the same acceleration. Clear everyone? So let me take the velocity of a jet point is ACOM because the center of mass, the velocity of acceleration of a center of mass is ACOM and velocity is VCOM and it is rotating with angular velocity omega and angular acceleration alpha and it is a what rotation everybody? It is the, yes please respond, it is the what? Pure rolling. Clear everybody? So now if you notice it, it is not moving forward or it is not slippering. It is not slippering means in the sense of, we all knows that slippering means in the sense of VC is equals to what? R omega. Am I right or wrong? At the point of contact. Correct everybody? Yes, please respond. It is not because it is a pure rolling. So that no slippery, no kind of forward or no kind of backward. Means in the sense of velocity of a P is equals to 0, velocity of a Z is equals to 0. If velocity is 0 means, can you tell me what is the acceleration about the P and acceleration of Z? Everybody, acceleration of P is equals to also 0 and acceleration of Z is equals to also what? Speak loudly. Acceleration of Z is equals to also 0. 0. Understand, Ra? Everybody? Yes? All of you? Respond. But if you notice it, basically if I take any point, if it is in a rolling or it is a circular motion, if I take this point, so always this body as it is rotating like this, so we all knows that it is rotating like this, so there will be two accelerations. Can you tell me what is the two accelerations we have? All of you? Yes, please. One is tangential acceleration and another one is which is acting towards the center. It is called as radial acceleration, or we can say radial acceleration also we can call it as a what? Yes, please. Centripetal acceleration. Am I right, Rudreswa? Clear? All of you? Yes, please. So now this tangential acceleration is equals to only what? R alpha, not R omega, R alpha. As we all knows that tangential acceleration is equals to R alpha. And can you tell me what is the radial acceleration is equals to? Radial acceleration is equals to R what? Radial acceleration, R omega square. Am I right or wrong? Tangential acceleration equals to R alpha. If it is the pure rotation, please remember, if it is the pure rotation, so acceleration of a center of mass is ACOM. So this particle also ACOM. So if it is a pure rotation, so what will happen everybody? ACOM minus R alpha is equals to 0. Do you understand everybody? In pure rolling, the acceleration, it is not contact. If it is not contact, the point at the point, if you notice it, it is always 0, but it is not always true also. Only if you take it, the tangential, all of you observe very carefully. If it is the pure rotation, so send acceleration of a center of mass minus R alpha. R alpha means what, guys? Tangential acceleration equals to 0. So from that, now if you notice it, but at this point, not two accelerations are acting. How many accelerations are acting? Rudreswar? How many accelerations are acting? One is ACOM, another one is A tangential, another acceleration is acting. What is that acceleration? Towards the center. What is that, guys?
Yes.
AR, that is what? Radial acceleration. So now if you notice it, so this is called it as a basically pure rolling. Pure rolling totally how many accelerations are acting? Everybody. How many accelerations are acting? 3 accelerations are acting. Now what I am saying, please write a statement. In pure rolling, all of you remember, the acceleration of point Z is not, it is not 0. It is not contact. Clear? It is not contact point is 0. Please remember. the contact point acceleration is not 0. That is wrong because 3 accelerations are acting. Which is wrong actually? 0. It is not true. Please remember, if I say in a pure rolling, the contacting point of the acceleration of this contacting point is 0, means that statement is wrong. Actually, the acceleration, the total acceleration of a point is not 0, because if it is rotating like this, then definitely the point Z will goes upward direction. The point will goes upward direction. So this acceleration of this point is not 0. Do you understand? It is not true. Only this tangential acceleration is equals to acceleration of center of mass. That is 0, not entire particle 0. Please remember. Are you understand what I'm saying? The acceleration of a particle is not 0. Tangential acceleration and center of mass acceleration is 0. That is what. So only tangential acceleration alone is 0. That is what you have to remember. So the center of mass acceleration minus r alpha means tangential acceleration, which is equals to 0. From that, acceleration is equals to, what will happen, everybody? R alpha is equals to ACOM, alpha is equals to, anybody can tell? Angular acceleration equals to, angular acceleration is equals to acceleration of a center of mass divided by radius. So this is the formula for calculating angular acceleration. Angular velocity is VCOM by R. Angular acceleration is ACOM by R. Both the cases, it is for what? Anybody can tell? This is for platform is in what? Stationary or motion? Everyone. Platform is in stationary. Do you understand? So ground is in stationary. That is the meaning. When the angular velocity is VCOM by R, angular acceleration is ACOM by R. So we all knows that VC is equals to R omega and AC is equals to what? AC is equals to R alpha. Understanding all of you? So that is what. So once again, I say, you remember, at the point of contact, acceleration is not 0. Please keep it in mind. If I say in a pure rolling, the acceleration of Z, which is contacting point is 0. If I say, it is wrong statement. It is not true, because when it is rolling with angular velocity omega, definitely this point will start displacing towards top. So definitely there will be a change in velocity, because velocity is not constant. Here if it will comes to here, we have studied root 2. If it will goes here, some other return. So that velocity changes, but the tangential tangential acceleration is 0. This at the point acceleration is not 0, but tangential acceleration with respect to ground is 0. That is what ACOM minus AT is equals to 0. So what is AT? AT is equals to what, everybody? AT is equals to what? You all people knows. AT is equals to tangential acceleration. Tangential acceleration is equals to R alpha. Can you tell me centripetal acceleration? Radial acceleration or centripetal acceleration equals to? Centripetal acceleration is R omega square. Clear? So that's what. So this acceleration is 0, but not the acceleration of the point. That is what you have to remember. Brothers, understand? Clear, everybody? Yes?
Yes, sir.
Yeah. So this
Yes,
is
sir.
actually for pure rolling. So now, but in this case, what? Ground is stationary. Platform is stationary. Now we are going to write if platform is not stationary. For example, imagine now there is a car and rolling is above the surface of the car, whose radius is R and centripetal acceleration is AC and angular acceleration is alpha. Angular acceleration is alpha. So this is actually, imagine like a pure rolling. Do you understand, everybody? Pure rolling. It is also pure rolling, but platform velocity is what? Platform is not in rest. Are you clear, everybody? So platform is not in rest. It is moving with the A naught. What is the acceleration of a platform? Who is the platform here? Car. So car acceleration is A naught. Just imagine. So what will happen, everybody? All of you. So I will give you option A. Option A, centripetal acceleration is equals to R alpha. Option B, AC minus A naught is equals to R alpha. Next option C, A naught minus AC is equals to R alpha. Option D, none of the above. So this is also 98% of cases. Next, the formula what we are going to get, 98% of cases it is true, because acceleration of a particular point is not zero, only tangential acceleration is zero. So let me see who will say the formula. Anybody can tell which is correct one? So imagine at this point, just imagine you can draw. So this is the point of contacting Z for a car surface. Okay, what is the car velocity, everybody? For a car acceleration is what? All of you. Car acceleration is, yes please. You all should speak. Car acceleration point is that platform is A naught. And what is the jet acceleration? AC, because it is from the center of acceleration AC. So now, and there is a tangential acceleration which is acting R alpha. So from that I can say, we all knows that AZ is equals to AP, which is equals to A naught, because point of contact, both are having they are relative motion. So their accelerations is remain same. So AZ is equals to AP is equals to A naught. So now from that I can say, everybody you can make it. So write the formula, everybody, what I can say, AZ is equals to AC minus R alpha, because if it is a platform velocity is zero, sorry, if the platform is zero, then what is the jet acceleration? Just now we have written. What is the point of jet acceleration? Speak loudly, guys. Here only we have written. Check it, everybody. ACOM minus R alpha is equals to what? Zero. But here, platform is not zero. Platform is having some velocity. That is what AZ. So platform velocity AZ is equals to ACOM minus R alpha. So now that's all, you can replace it. So AZ is equals to AC minus R alpha. So we all knows that AZ is equals to A naught, AC minus R alpha. R alpha will come this side, A naught will go that. So R alpha is equals to AC minus A naught. So which option is correct? Anybody? AC minus A naught is equals to R alpha. Which option is correct? Option?
B.
Option B. Please note it. Okay, everybody. So the point of contact and that part surface, both are having the same acceleration. So if you remember that point, that's all it is. So A naught, AZ and AP is equals to A naught only. And you can take it. Then tangential acceleration. We no need to consider about the centripetal acceleration. Please remember, sorry, radial acceleration does not matter. So which is equals to radial acceleration, which is equals to tangential, acceleration of center minus tangential acceleration is equals to acceleration of this particular point. What is that point? Which is equals to point of P, acceleration of point P, which is equals to A naught. AZ is equals to A naught. So in place of 0, I will write AZ. So that's all. If you replace, we all know AZ is equals to 0. If you replace it, you will get centripetal acceleration minus acceleration of a point platform is equals to tangential acceleration. That's all is the relation. I hope you all understand. Anybody having doubt, you can ask me. Are you clear for those? Understanding? So this is the 98% of cases. This is the formula, always acceleration. This is the formula which is true. You have to solve it. Then tomorrow we are going to study if it is a frictionless surface, then what will happen? Understanding? Then we have to calculate the velocity, and if it is a friction surface, then what will happen? Due to the friction, what will happen? That is all the things we are going to discuss in our tomorrow's class. I hope you all understand today's class. Any problem for anybody, you can ask me. Are you clear, everybody? Understanding? So 2 cases we are studying everything.
Yes,
Everything is pure rolling. One time platform is in stationary, another time platform is in what? Everyone? Platform is in motion. Understanding? Platform is also having some velocity. So if platform is having some velocity, what will happen? If platform is in stationary, what will happen? That is what you have to remember. So if you understand this, that's all it is. It is very simple. So please kindly go through that what we studied in our today's class. If you understand this, then tomorrow we are going to discuss frictionless surfaces. If it is a friction is existed, what is the velocities and all we'll discuss. So today's class we made velocity plus this one. So please remember, everybody, VC is equals to R omega, or we can say VC minus R omega is equals to V naught. This is when platform is having a velocity of V naught. So that velocity of platform and velocity of a point Z is equals to V naught. So same way now acceleration. AC is equals to R alpha. Now AC minus R alpha is equals to A naught. So that is what point Z with respect to relative motion. AZ and AP which is equals to A naught. So this is the things which you have to remember. These are the most important thing for our today's class. I hope you all learned, everybody. Is it easy, Laksha? Are you clear? Dresser? Understand, Dami?
Yes, sir.
And tomorrow we
Yes,
are
sir.
going to bring the moment of inertia again back into this concept. If I bought the torque, if I bought the moment of inertia, remember all the 5 chapters what we studied till now. If you bring it only, this next concepts we are going to study. You need vectors, you need motion in a straight line, you need a motion in a plane surface, everything. All the chapters, if you bring only, you can study this one. That is why this is the most important chapter. Okay. I hope you all understand. From here, we'll continue tomorrow. Please wake up morning and practice the questions related to that so that only you can excel in the exams. Okay. Thank you, everybody. We'll meet you tomorrow's class.